Section 5, Antarctica, the ocean's quiet center. When discussing global oceans, attention often focuses on the Pacific, Atlantic, or Indian basins. These regions host major shipping routes, fisheries, and coastal populations. They are heavily monitored and deeply integrated into the global economy. Antarctica occupies a very different position. Located at the southernmost point of the planet, the Antarctic continent is surrounded by the Southern Ocean, a vast circumglobal current system that connects the Atlantic, Pacific, and Indian Oceans. Rather than being separated by continental boundaries, the Southern Ocean flows continuously around Antarctica, driven by powerful winds and large-scale planetary circulation patterns. This circulation plays a critical role in Earth's climate system. The Antarctic Circumpolar Current, ACC, is the strongest ocean current on the planet. It transports enormous volumes of water around the continent, linking the world's ocean basins into a single, interconnected system. Through this circulation, the Southern Ocean helps regulate global heat distribution, carbon storage, and nutrient cycling. In many ways, Antarctica functions as a central regulator of planetary ocean dynamics. Ice, light, and biological productivity. Despite its harsh reputation, Antarctic waters support some of the most productive marine ecosystems on Earth. Seasonal sunlight cycles drive massive phytoplankton blooms in the Southern Ocean. These microscopic photosynthetic organisms form the base of a food web that supports krill, fish, seabirds, seals, and whales. Antarctic krill, Eupausia superba, are particularly important within this system. These small crustaceans form dense swarms that can extend for kilometers and serve as a primary food source for many larger marine animals. The health of Antarctic krill populations influences entire ecosystems, including species such as blue whales, humpback whales, and Antarctic penguins. Ice also plays a crucial ecological role. Sea ice forms and melts seasonally, shaping habitat conditions for numerous organisms. Algae grow on the underside of sea ice, providing food for small marine creatures that then support larger predators. Changes in sea ice patterns can therefore ripple through multiple levels of the food web. The Antarctic Treaty System. Unlike most continents, Antarctica is not governed by a single nation. In 1959, 12 countries signed the Antarctic Treaty, establishing Antarctica as a scientific preserve dedicated to peaceful research. The treaty prohibited military activity, nuclear explosions, and the disposal of radioactive waste on the continent. Over time, additional agreements expanded this framework into what is now known as the Antarctic Treaty System. The treaty represents one of the most successful examples of international cooperation in environmental governance. Scientists from multiple nations operate research stations across the continent, conducting studies in fields ranging from glaciology and atmospheric science to marine biology and astrophysics. The Protocol on Environmental Protection to the Antarctic Treaty, often called the Madrid Protocol, further strengthened environmental protections in 1991. Banning mineral resource activities and establishing comprehensive conservation measures. In a world often divided by geopolitical competition, Antarctica stands as an unusual example of collaborative stewardship. Antarctica as a scientific observatory. Antarctica's geographic isolation and environmental conditions make it uniquely valuable for scientific research. Ice cores drilled from the Antarctic ice sheet preserve atmospheric samples dating back hundreds of thousands of years. By analyzing trapped air bubbles within these cores, scientists can reconstruct past climate conditions and track changes in greenhouse gas concentrations over time. These records have played a crucial role in understanding Earth's climate history. The Antarctic Plateau also provides exceptionally clear atmospheric conditions for astronomy and astrophysics. Instruments located at research stations such as the South Pole can observe cosmic radiation and other phenomena with minimal interference from atmospheric moisture or light pollution. In addition, Antarctica hosts specialized experiments designed to detect elusive particles such as neutrinos, using large volumes of ice as detection media. One example is the IceCube Neutrino Observatory, a massive detector embedded deep within Antarctic ice. These scientific installations transform Antarctica into a global observatory for studying both Earth and the universe. Did you enjoy this essay? Let me know below. Like and follow for more.